Hello YouTube, this is Frank, and this is April the 15th, Wednesday, April the 15th, and this is my 18th video and my 12th topical video. And I was going to continue with the coronavirus topic, and I want to look at the data from Italy. Italy is several weeks ahead of the United States, and I think it's very helpful to look at the data from Italy. This weekend, I made a spreadsheet for Italy and all the United States and all the 50 states. Now I will be changing the slope of the SIR curves. Now this is the board from yesterday. I'll be now, my source of data is Wikipedia. It's publicly available. I don't think it has a copyright on there, but anyway, that's where I get my source for the 50 states. Now I'll be looking at the cumulative deaths. That's from Wikipedia, deaths per day, and I do not have the second derivative plotted, but I think it's very useful to look at that deaths per day plot. Now also another source is the source for information on the coronavirus is the National Academy of Sciences, and they have some very good information. Now in my spreadsheets, I will hold all of my constants, all of my parameters constant, except for the interaction rate, and that's the social distancing parameter. That's the that certainly changes because we've pretty much locked down, closed down a lot of businesses here in the United States. Now, when we plot that data from Italy, I think it's going to be very helpful. I know there's a lot of talk about opening up the economy in the United States. So let's look at Italy, since they're ahead of us, and see what the curves look like. Now there's the second derivative. If it is positive, that's concave up, increasing speed. If the second derivative is negative, that's concave down. And there's our decreasing speed. So decreasing, the rate of change is decreasing. So let's look at what we've got here. Yeah, this is April the 15th, Wednesday, April the 15th. This is the CDC, the page on CDC, and they're showing 24,500 deaths cumulative. So that's that's and we're still a long ways from this thing being over. Now this is the page from the National Academy of Sciences. They have a very good news and resource page here if you're interested in the reading more about this. So let's see here now. What have I? Now this is the spreadsheet from yesterday. So there's the cumulative deaths from the idealized corona land. There's the number of deaths per day increasing, and they're decreasing. And there's the second derivative. It's the speed of the change is increasing, and then when it goes negative, well, there's at zero. If it's zero, there's no change. And it's negative, and the rate of change is negative. So there's our concave down and the concave up. So let's see here. Yes, this weekend I made a spreadsheet for every state in the United States. And I'll put that on my Google Drive. Let's look at let's look at the Italy one. Let's see, let's get over here. See, there's my, I'm just using buckets of 100,000, and there's 60.3 million population in Italy. So that makes that there will be 603 buckets of 100,000. So let's get over here, and let's just plot the cumulative deaths here. Oops, wrong button. Oops, there we go. We went right past it. Okay, now the red line, that is the observed deaths, cumulative deaths in Italy. Now, if you look at that, it's kind of hard to see where the where that second derivative is zero, where there's the kind of the concave up, and it's kind of hard to see where the concave down is. So and I've got it over here. Let me get over here. Now in these columns, I've got. Now this is the change in deaths. So the deaths per day. That's the cumulative deaths. And so if I subtract the day minus 1, I'll get the deaths per day. So let's plot this. There we go. Now this is, you can see in Italy there's that peak right there. Of course the data is kind of is noisy. Now I did fit. There's the blue. Is that blue? I guess it's blue. That's from my model that's trying to fit that curve, and you can see where I'm kind of fitting the slope of the curve going up. There's the where it kind of turns around and goes negative. But right here though, I'm not sure what that is doing. You know, if Italy has relaxed their social distancing, are they allowing people to come back and allowing the virus to come back? I don't know, and that's the reason why I was looking at Italy, is because they're past their peak. You know, we can see that, and then did they relax their social distancing? And is that, you know, you wonder if that's going to be steady, decreasing or increasing, and that's one of the countries I want to watch, because the United States, not sure, and the deaths, I believe, are from what I understand, is a lagging variable, I guess, from the epidemic. I think the hospitalizations and the diagnosis of the coronavirus, I think those are leading variables, but I don't have access to any of that, or readily access. So this is what I think, you know, there's a good bit of talk about opening up the economy in the United States. So let's just look at what I've got over here. So those are those variables. I'm keeping the infection rate constant, the mild, severe, and the death rate constant. And the only thing I'm changing is the social distancing. And you can see where I've changed the social distancing to fit that slope, that curve over here. So if I were to move this graph, I wonder, can I move it? Okay, yeah, that's me. Let me move it up just a little bit more. Now, the only thing I'm changing is the social distancing, and I do that. Let me see here. I do that every. Move this over just a little bit. Every Friday, I do that every Friday. I change the social distancing parameter from my model. So let's move this back a little bit. And watch this. Now, if I change the not on this column right here, that is not used. I just use that to remind myself of what this value is. I mean, if I change it, I want to try to remember what the original value was. And now also, let me just get back over here to this thing. Let me see if I can get that. I can't quite grab that axis there. Well, okay, so that's, let's see what, oops. So if I were to change this variable here, our social distancing thing from 28 to 20 and recalculate. There's that, it moves the curve from that starting date, you know, up to, well, it moved it down because I decreased the social distancing. So what I did every week was move that curve. So if I were to make that 25, and watch this right here. So it moves the whole curve from that beginning of that week up there. So that's, so if I were to change that to 28, that's what I had right there. Let me see if I can go up to 28. And there. And I'm just fitting that my model, that the simple SIR model, to fit the observed cumulative deaths right there. And this, it's very striking over. Oops, went past it. Let me grab this here and move. Can I move it? Let's see if I can move it up here. And I'm going to move it on top of this graph right here for right now, just so we can see the thing. All right, I'm going to change that again. Now watch the. Oops, let me get over here. I want to change that to 20. Right there. Let me see if I can do that. Now watch the that curve. See that's it moves that the model down. That's the observed data, and what I'm doing is trying to fit the model to the data over there. And I'm just, the only thing I'm changing is the social distancing. So if I were to change that to 25, and see, it brings it up, brings the whole thing up from beginning that week. I believe that was in February. It brings the whole thing up. So let's see. Let's see here. 28. There. And so I every week I just went by every week. Let's see. Let me bring this here thing down. Okay, so this is March the 13th over here. Okay, now watch the. So if I were to change this to, I don't know, 28. Now it should only from that point on does it affect the curve. Yeah, that's it. From that week on, and so what I did. So let's just change that back. So there's where our original one was 8 right there. Okay, so I just every week I just fit these social distancing to match that curve, the observed data, from Italy. Now, up here, it started out at 50, then in March it was going down to 8, 6, and then in April I had to use 2.5 to fit that, to make that curve bend over here. Let's see. To make it, yes, to give that negative slope right there. And that's a 2.5. Now let's look at my other ones that I've got here. Can I get a, let's just look at the USA. Okay, now, the USA is, I think, several weeks behind Italy. Hear a train coming, so I'm going to have to finish this up pretty quick. Let's just plot that. There's the slope, there's the observed this, and I got that from the CDC. Okay, so let's go over here to the deaths per day. Oops. Chart. I won't scatter. And see, you know, this is the curve from the U.S. It's hard to tell whether that thing is bending that way or not. That's April the 15th today. Now, some sources were showing 30,000 deaths in the United States. So I'm not sure how, you know, which if we have reached a peak yet. But anyway, I've got a spreadsheet for the USA, Italy, and all the 50 states here, and I thought I would update this. Let me see if I can get back over here. I'll just update my graph every Friday. Now I did notice, see, there's 6.8. I haven't had to use the 2.5 to bend that curve over to fit the data yet. I'm not sure if we've reached the peak in the USA. But anyway, that's what I was looking at this weekend. And all right, thank you for watching.